we are continuing with the module 3, and in this session we will be discussing about the production of solar grade silicon by union carbide process. This process is also called as a carbothermic process, and here we are synthesizing the silicon which is required for our solar cells. Okay, so silicon is one of the important compound which is used in the making of the PN junction. Okay, so here it is synthesized by using the following two steps. The first step one is synthesis of the metallurgical grade silicon, and then the conversion of the metallurgical grade silicon into the required solar grade silicon. Okay, and the solar grade silicon is obtained by the following ways. Here two types of silicon is available here. One is the metallurgical grade silicon and the other one is a semiconductor grade silicon. Okay, as in the name says, metallurgical grade silicon. Okay, when we say metallurgy, the metal will be containing like large amount of impurities. No, in the same way, the metallurgical grade silicon will have both intentional and unintentional impurities. And when we come to the solar semiconductor grade silicon, the semiconductor grade silicon will be almost pure in nature. It will not contain any impurities at all. But what do we need? We need a silicon which is intermediate between these two. We need a silicon which is intermediate between metallurgical grade silicon and semiconductor grade silicon. Okay, what is the meaning? A silicon which should have less impurities than the metallurgical grade silicon, and that silicon which is having more impurities than the semiconductor grade silicon, that we are synthesizing here. That is by two steps. First step is the synthesis or the manufacture of the metallurgical grade silicon. How to do it? When silica is reduced to silicon by heating it with carbon in an electric arc furnace at a temperature of around 1500 to 2000 degree centigrades. When coke or quartz is heated with the silicon dioxide, it will be giving rise to the silicon and carbon monoxide. The carbon monoxide formed will be oxidized to carbon dioxide and left to the atmosphere. And then after the silicon is formed here, we have to remove the impurities present, right? Okay, so that silicon, through the silicon liquid, we have to pass fresh air, or we have to mix with the silica as a flux to remove the impurities like aluminum, magnesium and calcium if they are present there. Okay, so what we should do? We have to add some silica flux to that and heat. Okay, if the impurities like aluminum, magnesium or calcium is present, they are oxidized to their particular oxides, like aluminum to alumina, magnesium to magnesium oxide and calcium to calcium oxide, and they will be forming a slag that can be removed easily. Okay, and thus even here some silicon is obtained here, and thus obtained silicon will be poured into the molds, okay, to get a required shape of the silicon. This silicon obtained is called as a metallurgical grade silicon. Till here I think I am clear. Okay, when coke or quartz is heated with the silicon dioxide at a temperature of around 1000 to 1500 degrees, silicon liquid is obtained, and we have to mix it with some flux or fresh oxygen to remove the impurities like aluminum, magnesium and calcium if it is present. If they are present, they will be oxidized to their particular oxides and it will be forming as a slag, and the slag will be removed, and thus obtained silicon is called as metallurgical grade silicon, and that will be poured into the molds to get a required shape of the silicon. Next is conversion of the metallurgical grade silicon into the solar grade silicon. Okay, how to convert this? Here the first step is the metallurgical grade silicon is refined by heating it with the HCl gas at a temperature of around 300 degrees to get a trichloro and tetrachlorosilane. Okay, the metallurgical grade silicon is treated with the hydrochloric acid gas at a temperature of around 300 degrees to get a tetrachlorosilane SiCl4. Next step is the tetrachlorosilane formed is treated with the hydrogen gas at a temperature of around 1000 degrees centigrades to get a trichlorosilane. You can just assume the reaction what is happening here. Hydrogen gas, no, usually it will be catching fire at room temperature, right? Okay, see here for the conversion, what is the conditions needed here? Okay, SiCl4 is heated with hydrogen gas at a temperature of around 1000 degrees. Then only we will be getting a trichlorosilane. Okay, Here the reaction is very simple. You have to remember, adding directly hydrogen to the silicon is very difficult. Substitution is taking place here. Okay, so what are we doing here? When we are treating the metallurgical grade silicon with the hydrochloric acid gas, SiCl4 is formed. Formation of SiCl4 is easy than SiH4. Okay, so after getting SiCl4, what are we doing step by step? One mole of the chloride is removed. In that place, 1 mole of hydrogen is attached. Okay, remember like that. It's very easy. When one chloride is removed, in that place we are adding 1 hydrogen. That's all is happening here. Okay, so the tetrachlorosilane, when it is heated with 1000 degrees with hydrogen, we will be getting a trichlorosilane. Tetrachlorosilane in presence of hydrogen gas at 1000 degrees will give a trichlorosilane. In the next step, the trichlorosilane formed is passed through a fixed bed columns will be there. They contain ion exchange resins. What type of ion exchange resins? Quaternary ammonium ion exchange resin is used here as a catalyst. Okay, they will be exchanging the ions here for the H plus will be replaced in the place of chloride ions. Okay, so we will be getting dichlorosilane and silane respectively. Okay, clear? No? The trichlorosilane obtained here is passed through a columns containing quaternary ammonium ion exchange resins. When we pass through these columns, what happens here is the chlorides are there which are replaced with hydrogen. Finally, we are getting the product silane, SiH4, and then pyrolysis is carried out here. Okay, silane obtained in the above step is subjected to pyrolysis in at high temperature. In pyrolysis reactor, pure silicon rods are used here for heating. Silicon formed by decomposition of silane gets deposited over these pure silicon rods. Okay, the reaction here is SiH4, silane is there. Okay, when it is carried out to the pyrolysis process, it will be giving silicon and hydrogen as the products, and thus obtained silicon is known as a solar grade silicon, and it can be further purified by zone refining. Okay, if further good quality of the silicon is required, okay, the impurities present can be further removed by using a zone refining process. Okay, so here the main points to remember is in the production of our required solar grade silicon, there are mainly 2 steps. First one is the synthesis of the metallurgical grade silicon. How the metallurgical grade silicon is synthesized? One coke or quartz is heated with the SiO2 in at high temperatures of around 1000 to 1500 degrees centigrade. Silicon is obtained with carbon monoxide. Carbon monoxide obtained is oxidized to carbon dioxide and left to the atmosphere. And if any impurities like aluminum, magnesium and calcium is there, it will be either treated with the oxygen or silica flux will be used here. If any impurities, aluminum, magnesium and calcium are present, they will be converted into that particular oxide and it will be forming a slag, and that is removed. And thus obtained silicon here is referred to as a metallurgical grade silicon, and that is poured to the molds to get a required shape of the silicon. Next is conversion of the metallurgical grade silicon into our required solar grade silicon. In that first step is we have to heat the metallurgical grade silicon with the hydrochloric acid gas with at around 300 degrees centigrade. We will be getting SiCl4 tetrachlorosilane. Then tetrachlorosilane is treated with hydrogen gas at a temperature of around 1000 degrees to get a trichlorosilane. Then after that, the trichlorosilane is passed through a columns containing a quaternary ammonium ion exchange resins to get a dichlorosilane, and finally the silane. Silane formula is SiH4. The formed silane is pyrolyzed. Okay, what is the pyrolysis? At high temperatures, no, breaking at high temperature, pyro. Okay, lysis is breaking, pyro means at high temperatures. Okay, here decomposition followed by distillation will be taking place, and the SiH4 will be giving rise to the silicon and hydrogen as the products, and thus obtained silicon is known as our required solar grade silicon. If further pure quality of the silicon is required, we have to carry out the zone refining process to get a still more pure form of the silicon. Thank you.